Good afternoon and welcome to this presentation. So in the next 45 minutes, I will try to give you an overview of our simulation portfolio, how simulation is power for our customer in the future of making things. I will first give a few words about myself, and then I will speak about different products with some real examples. And I will talk a little bit about future technologies that Autodesk is incubating. So my name is Benoit. I'm technical sales specialist for Europe. I'm based in France, near Strasbourg. And I joined Autodesk in 2001 by an acquisition. So during the last 25 years, I spent almost my time in mechanical engineering in several companies and joined 10 years ago the software as an application engineer for CFD. So the future of making things presents an extremely exciting opportunity, but it can also be challenging for our customers. Technologies, material, environment, and manufacturing processes are changing really rapidly. Autodesk is uniquely positioned to assist engineers with this transformation, providing the latest technology, democratizing it for all, and promoting the use of early and iterative simulation solution in both the desktop and the cloud, static and mobile. Connected and remote is where we feel our impact will be maximized. Our aim to help analysts, engineers, and designers achieve their goal via simulation-driven design and advanced material analysis. A complete portfolio of solutions, which I will speak a little bit later, the next slide, enable our customer to solve both upfront and advanced engineering challenges in cost-effective manner. I can say with confidence that also in the industry is evolving rapidly and no one has all the answer at this point. We are committed to help you realize the most effective and profitable future state possible by helping increasing innovation capacity, reduce time to market, and mitigate risk. So a quick look to the today Autodesk portfolio. The first point to mention is that we have two big pillars. On the left, we have the upfront simulation. On the right, the advanced material solutions. Working from left to right, first we have simulation CFD that is integrated with almost all the CAD system, allows engineers to solve fluid, flow, and thermal problems. Then we have Nastron in CAD solution that is fully embedded in Inventor and SolidWorks. That is a non-linear structural analysis. Then we have Autodesk Simulation Mechanical. That's a standalone product that works with almost all the CAD system and help you to solve high-end finite element analysis, but also mechanical event simulation. On the right, you can see the advanced material portfolio for performance and lightweighting. So we have Moldflow, Helios, and Nastron are proven, established, and mature technology. I will speak a little bit more in detail later about these different products. So let's start with Moldflow. Many enhancements were incorporated in Moldflow 2017. You have to know that almost all the improvements came from existing customers. It includes Musel with Coreback, microcellular injection molding, transfer of thermal profile for two-shot, overmold cooling, and more than that. However, what is really changing the game for our customer is the multi-user subscription, and especially for Moldflow, leveraging the cloud and design of experience. By adding cloud service entitlement, design of experience in the cloud become a cost-effective option for any engineer to run statistical analysis to understand how processing conditions have the greatest impact on a given quality indicator. The interface for DAO becomes really easy to use. And the job manager provides transparent access to the cloud, meaning that you can easily mix and match local and cloud runs by flipping a switch. No additional coding is required. You can analyze the influence of variable on specified quality criteria. You have unlimited processing power to determine the sensitivity of variable and optimum solution conditions. And this is available for every mesh type, molding processes, and analysis sequences. Now we'll speak about Helios. So as referenced earlier, we have made significant advancement in solver development as well as interoperability for incorporating fiber orientation and as molded stress into nonlinear structural analysis. So Helios PFA is a solution that allows you to utilize the as-manufactured material property from an injection molded part for non-linear structural analysis on your part or assembly. Here we see the workflow for mapping the Autodesk Moldflow results for a set of 2 injection molded parts to a structural analysis. FIA model using the Helios PFA software. The mapping capability of Helios PFA allow you to transfer the results of the manufacturing simulation to the structural analysis model. The model can have 2 different meshes. Element type can be even completely different, and even geometry can be different that reflect post-molding modification like cutting, trimming, and drilling. There is a built-in mapping suitability plot that allows you to evaluate the accuracy of the results before mapping. For this example, there were 3 sets of Moldflow results that have been mapped to the structural model. Fiber orientation that affect the local stiffness and build plastic. Cut planes allows you to visualize the distribution of fiber orientation through the thickness of the part. For structural assemblies, differentiating between the tensile and compressible behavior is vital for as plastics exhibit different behavior in tension than in compression. In assemblies, parts are oftentimes placed in compression. Capturing the behavior will lead to the greatest accuracy in your simulation. This example was a multi-part assembly. So after you have mapped one part, you can simply pair an additional Moldflow simulation with another part within your structural assembly. This allows you to get the most accurate structural simulation of your plastic material, as you can now take in account the effect of the injection molding process. The other really important part, and as I mentioned earlier, we have added the ability to predict the strength of weld surface using the process history in 3D weld surface point. This technology results of a doctoral thesis of one of our team members that dedicated a significant amount of time to ensure the weld line calculations are robust, accurate, and include the complete range of front weld lines profiles. So Helios PFA can predict the strength of each weld point based on his process history, including the temperature, the pressure, and the flow front meeting angles. This information allows a model to have a spatially varying weld line strength prediction, which is completely dependent of the history of each point. Let's have a look to this example. On the top example, it's a one point injection analysis. So without weld lines, and we can see that we predicted the breakage like it's on the real part, and the strength is corresponding to the blue curve. On the bottom, we have two injection points. So we got a weld line in the middle. So it's really easy and obvious to predict that the part will break where we have weld lines, but not that easy to predict the value, and especially not using a structural analysis tool. So I can also say that we have several well-known automotive companies using this technology, mostly for interior and exterior components, where we have already some really interesting correlation. I want to share with you this quick customer testimonial to the power of incorporating as molded stress and strain into FEA. Guangzhou Automotive is a Chinese partner of Toyota, Honda, Mitsubishi, Fiat Chrysler, and they cover the design and manufacturing of vehicles of parts from domestic and foreign markets. They use Helios PFA and import residual strain results from mold flow into FEA. From there, they apply the load and boundary condition to simulate bolted and condition and provide as-built results for the component. This lets them understand if parts will interfere and if sufficient clearance exists between parts. They also leverage Autodesk Helios PFA to explore more advanced material model for their design. They are testing fiber, reinforced polymer, and other untraditional materials. They design bumpers, oil pans, and other components to continue to lower the cost of each part and ensure that all the components will remain strong enough in the usage. Now we will switch gear and have a look to Autodesk Cfd, which is fundamentally a virtual flow test bench and like a thermal camera. So we will start with a really short example of a choke valve, whether using SolidWorks, ProEngineer, NX, or Inventor native model, you can. It allows you rapidly to explore multiple design scenarios. We'll set up several cage design, and the target will be to minimize the pressure drop, directing cavitation or bulb away from the walls, and remaining below a specific velocity and a pressure drop with a given flow rate. Ultimately, we want to maximize performance. Cloning studies and leverage the associativity of the geometry will help you to have multiple design and be able to analyze the pressure drop to get the pressure drop results, comparing all the different results. This helps you also with other tools in the design study environment to get some more information, like here, the velocity along a curve. And this is for all the different designs. Another common application for Autodesk Cfd is electronic cooling. This NVIDIA heatsink was evaluated to ensure maximum heat transfer by normalized the flow through the heatsink fans. The baseline design was found to underperform due to impingement of the airflow between the fans' fin. Ironically, removing a little bit of the heatsink that we can see here on the right side increased the heatsink performance. And here we can see the air velocity distribution between the fins and here the corresponding temperature. So removing some material of the heatsink improved the airflow and the performance. Lastly, Autodesk Cfd has a long history in the building environment. Data center, parking garage, lab space can all benefit from HVAC or external air study to maximize air quality. This is a really more fun example, but show the winds effect on a soccer match. A few customer examples. The first one for high performance building design from Sudlows, a unified infrastructure specialist company from the UK. They focus on innovative and sustainable technical solutions for data center. One of the users said that with CFD we are able to experience different scenarios, how to set up an energy efficient data center infrastructure. Without SimCFD, we just used experience and rule of thumb which led to quality and inefficiency problem in the data center operation. Betts Industry is another company and a great example that is using CFD successfully for simulation-driven design. So they use CFD really early in their design process. Today they use PTC solution as their CAD system, but leveraging the native interaction allowed their design engineer to virtually optimize the performance by 33%, and they were able to reduce by more than 50% the development cycle. Another product will be into the FEA world with simulation mechanical, and I will focus more today on the interoperability with all the other simulation products. Simulation mechanical directly interfere, I don't know if the video started. Yeah, Autodesk Mechanical directly interface with Autodesk Cfd. So complex temperature gradient, pressure due to the flow effect, or both can be coupled with any additional load or constraint to consider the structural consequences. I'm not sure that the video is running. Can you just have a look, please, if the video is running? No, sorry, something is wrong with this video. So, we are able to map the temperature, the pressure from CFD to mechanical that becomes a load case directly for the structural analysis. Another interoperability, and yeah, now the video is working here, is with mold flow. So we can directly read mold flow results to define the material property in sim mechanical. So this is really helpful to get the fiber orientation and to get the residual stress from the molding process. So integrating as molded data downstream into the mechanical analysis is critical to accurately capture material behavior for plastic parts. So this stress and strain displacement will all take the information in account. So this is the first step that we can go further than this one using Helios PFA, for example. So that was a quick tour of our simulation portfolio. Now I want to talk a little bit more about additional services that Autodesk simulation team can provide. Often we have customers that need help to define their processes or optimize a product. Other customers that need some mentoring time or specific implementation help. Our service team can provide this type of work. It's a paid project usually that is articulated in 3 steps. First, they will scope the project, then deliver a statement of work, and then we execute the job according to this plan. We also what is called an health check program. So that is a program that is, the target is to link and to connect the technical team of Autodesk with the customer to better understand how you use the product and what your design processes are. We also review together the actual usage of the Autodesk product. We can share with you best practices. We help you to connect directly with the technical support. And then we can come back with some best practices, tips and tricks. So we started this health check program in 2014, and so far we perform about 1,000, and usually the customers are happy to interact around the simulation product with our technical team. We also have 2 material test labs because material data is one of the most critical and important input and critical factor that can influence the simulation accuracy. So we have 1 test lab in Australia, 1 in the US, in Ithaca, New York. And we support both thermoplastic and thermostat testing, as well as linear and non-linear mechanical testing for Helios PFA. So we can provide all the tests needed to run non-linear analysis. So we covered the existing product. with an overview of the portfolio, the associated service that Autodesk can provide to make our customer successful. Now we will have a look to what's next. How products will be or can be designed and manufactured in the future, and what solution are we bringing to the market to help make that a reality. So we are moving aggressively into creating organic shapes with both topological and lattice optimization, where we are creating this organic shape in real time based on operation condition and having the simulation happening in real time. So what does that mean? We can put some loads on this part, and the solvers are running stiffness analysis, and we are changing the shape. So it's a loop analysis that at the end will give you this type of geometry depending on the type of algorithm you give and on the different constraint you fix. You can ask to have here a surface, and a given load. So automatically we can optimize parts for lightweighting. As Callan told this morning, in aerospace, light is like gold, with load requirements or with given displacement. And we can, as you can see, this part cannot be produced with actual or standard manufacturing process. So we really also try to connect that with 3D printing. So this is an example that you already saw this morning, and that's the Airbus bulkhead that was made using generative design. And yeah, we know that the parts were already produced. We will have one of the parts really soon on a trade show, and probably next year, as Callan told, perhaps we will already have this type of part in an aircraft, in an Airbus one. So that's an interesting example using this technology. And I just want to finish with another type of example of how today some customer start the design using shape generator. So that means you can block the different bearings here, and with given loads you can try to define the best design. And you could try to machine this part first, or you could decide to use an injected molded part. Why not some advanced injection molding processes like gas-assisted injection molding with fibers? So for that you would use mold flow, or even more, you could decide to go to 3D printing. So using shape generator, you got an answer of a geometry, and then you can try or decide which one of the manufacturing process you would use. And to validate the right process, we use today Autodesk and Nastran in CAD. That is today the best solution for nonlinear analysis embedded fully within Inventor. So just to recap, Autodesk customer today benefits from our flexibility and commitment and operability of our existing portfolio. We are working and rapidly developing or acquiring new advanced capability and to integrate them in our existing solution. And the future of making things is already now and has already started. And we are committed to Autodesk to help you in your success with our simulation portfolio and solution. Thank you for listening.